with that, I will get started. Thanks for joining the October meeting. You got a great series of 3 speakers focused around universities, higher education, green building standards, embodied carbon. And let me share my screen of the lists of guests or of presenters. How's that, everyone? Oh, I lost everyone's faces, but hopefully you can see that. So as I mentioned, this month's presenters will be talking about standards for green buildings on a campus-wide basis. And first presenter is Lisa Dulude. Lisa Dulude is the Director of Sustainability for the University of Washington, where she and her team lead innovative and equitable solutions around sustainability, including UW's Sustainability Action Plan, Tri-Campus Decarbonization, UW's Green Building Standard, and more. Prior to joining the University of Washington, she served as Snohomish County's Energy and Sustainability Manager for 12 years. She holds a bachelor's in environmental studies from Bates College in Lewiston, Maine, and a master's in urban design and planning from the University of Washington. Lisa, thanks for joining us. And I'm going to stop and allow you to share your screen.
Okay, thank you so much, and appreciate the invitation and opportunity to share a little bit about what we're working on at UW. Okay. That's me. Is everyone seeing presentation mode now?
Yes.
Okay, great. All right, so just a quick introduction. I like to let people know that UW does have an Office of Sustainability. This is our small but mighty team. And the Green Building Standard that I'm going to talk about is generally something that if you have questions about, I'm your point person, but Marilyn Ostergren on our screen here is also somebody that you could reach out to if you have questions. UW quick, fast facts. I'm guessing because this is a local crowd, everyone's familiar with UW, but we've been around a while, since 1861. We have 3 campuses, Seattle, Bothell, and Tacoma. Lot of acreage, 50,000+ students, 100+ undergraduate majors, and we are an R1 research institution. Go Dogs. Okay, so I did want to just point out that we've the significance of embodied carbon and emissions related to new construction. So a few years ago, we conducted a new greenhouse gas emissions inventory for the entire organization across the tri-campus. We included goods and services for the first time ever, and I broke that out, broke construction out just for this graph so that you can see in terms of magnitude and where our emissions come from. This is a really significant source. And I like to just provide that for context at 7%. Okay. So the Green Building Standard, just going to touch quickly on applicability and rollout. So this new standard that was put into place about a year ago applies to all of our capital projects, so not just building projects in Washington State. It includes all properties and spaces that are owned and operated by UW, all campuses and satellite locations. It applies to all of our divisions, departments, and units, so both academic colleges, UW Medicine and Healthcare, et cetera, athletics, and it's for projects that are over $1 million. So phase 1 of this new standard took effect July 1st of last year. We did have a couple projects that were already formed prior to that date. And so they've been sort of on that transition of doing what they can with the budget established. But everything moving forward that was formed after that date is under the full new Green Building Standard, or GBS. All right. And a very high level overview, if you go to our Green Building Standard website, you will see what I've cut and pasted in the screenshot to the right. But we have a number of different documents that really comprise the standard itself. So the first is the Green Building Standard, so a relatively long document that you might expect that gives you sort of the ins and outs of applicability, what requirements go with what projects, et cetera. We also have a UW lead specific checklist. I'll talk a little bit more about that and some of these others in a minute. We have a document that is a life cycle cost assessment or analysis that is required. We have new bird friendly guidelines. We have a process map and a workbook, and I'll talk a little bit more about these in a minute. But also just want to point out on the right-hand column, if you go to our website, that is where you would find all of this stuff. So for any of you that have worked on UW projects in the past, we had a pre-existing green building standard that was very simple. It was 3 items. We required LEED Gold certification. We had an energy use intensity target and a water and use intensity target. And one of the sort of opportunities, I guess, we found with the old standard and moving to the new standard is that we really wanted to address more than just new construction and major projects, I would say. The old standard really wasn't specific about what projects it did or didn't cover. So the new one is very specific. So you'll see all the different project tiers on the left-hand side of your screen. So tier 1 is what we call major projects or major renovations and new construction. Tier 2A is partial building renovations. Tier 2B is interior projects. Tier 3 is system upgrades, so really things that touch energy and water, major energy and water systems. And tier 4 is non-energy projects. So we're covering a much wider scope than our previous GBS. And then over on the right, this is sort of a high-level overview of the different targets that projects have to meet. So depending on the project, whether it's housing, like dormitory housing, or something else, laboratory space, the water use requirement could be anywhere from 25 to 40% below code. Our energy or EUI requirements, we want it to be better than the state requirements, primarily because, at least at the Seattle campus, we need to meet the state and local EUI and decarb requirements as a campus on a district energy system. We are still requiring LEED Gold, and as I mentioned, we have a new UW scorecard that has some required credits in addition to the prerequisites on it. For the first time ever, we have an embodied carbon project target, and that also includes material-specific requirements as well. So that's pretty exciting. For ecology, sort of the big new thing here that I mentioned is the bird-friendly guidelines, and they were created by a PhD student. I've kept that typo there that says UW friendly bird guidelines just because I think it's hilarious. We like birds, friendly or not friendly. For health and wellness, we want projects to pilot a Fitwel credit, and if they're building a facility where they would have bathrooms and showers, we want those projects to include showers and changing facilities. And then as far as equity, we are also requiring lactation facilities and gender neutral restrooms, again, where it fits into the scope of the project. And then at the bottom, those 3 bullets are also really important. So we have said no new fossil fuels in any of our projects at UW. That excludes backup or emergency power, generators, et cetera. As I mentioned, we require that life cycle cost assessment or analysis for all of our projects, and they have to connect to the district energy system. And that is because UW has a big plan in place, long-term plan to transition off of fossil fuels and fully electrify our central plant. Okay, so as far as embodied carbon, we actually developed this about a year ago for our facilities and UW leadership. To help answer some questions that they had about embodied carbon. So I thought this might be useful for any of you if you do work for an organization that's considering an embodied carbon requirement, this helped sort of educate our leadership about what we were going to require before this was officially adopted. So all projects have to meet product requirements for embodied carbon. And essentially we're saying you have to look at the CLF's materials baseline report and meet those as the product specific specifications. Tier 1 and Tier 2 projects also have a design target that you saw on the previous slide. And then we also want to see the construction actuals. And for the most part, we are referring folks to the EC3 tool. Some projects, when we have, our larger projects, we have the consultants on board that actually have some of their own tools to look at and model embodied carbon, and that's fine. And then we also wanted to just give leadership a general idea of what the costs, additional costs would be. And a lot of these are more of those, excuse me, those soft costs for the consultants that we bring on board. This actually ended up being really fortuitous that we put this in place because the state's Buy Clean, Buy Fair Act is also now official, and so we were ahead of the game in that sense, that we've already set up this requirement and a reporting mechanism internally to capture that data. As far as the life cycle cost analysis, we really want to make sure, this isn't to say UW isn't already doing life cycle cost analyses on our projects. We are, and I think we're really doing a great job on it. But this helps reinforce that life cycle cost analysis on smaller projects, things that might be in that tier 3 category. If we're replacing a boiler, for example, or a portion of a mechanical system in a building, this will just help ensure that projects not only on our tri-campus, but also some of the healthcare projects across the state comply with those EUI, help us move the EUI needle down to where it needs to be to meet some of those state requirements. Okay. For EUI targets, as I'm sure all of you know, they're required by the state Clean Building Performance Standard and City of Seattle BEPS. Again, this across the board sort of organizational green building standard really helps ensure that all of our different properties are complying. And whether it's sort of an incremental, like I mentioned before, change in a system or a portion of a system, or whether we're building an entire new building, this is sort of a mechanism to help ensure compliance and progress in that regard. And yeah, I think everybody knows, I've sort of said this, but we are, especially the Seattle campus, our EUI is double that of our institutional R1 peers. And so making this a requirement for more than just new construction, but also for renovation and mechanical evaluation and selection is another important lever to help push that progress forward. One of the things that we really tried to do with the new green building standard is make sure that we didn't just publish the standard and its content and then tell our campus architecture and planning team and our project delivery group, good luck. We really wanted to also give them tools to help, and of course our design build professionals and all of the great consultants that work with UW, some better tools to help ensure that everybody's on the same page throughout the process. So I just put a screenshot in here on the left of our process map, which is very helpful in terms of from soup to nuts, project conceptual, as the project's coming into conceptual design, all the way through transition to occupancy. We have these sort of helpful maps of who's taking the lead on what you should be doing at that phase or sub-phase of a project in development. And then on the right, I have a screenshot of our UW Green Building Standard Workbook. So this is really our tracking and reporting tool for design teams and for our PMs on the project. It's also really helpful for teams in determining the tier that the project is in. So we wanted to help reduce the number of questions our small but mighty team got on what tier is my project in, whether they're doing a big ADA ramp on Red Square or whether they're building a new building. This tool not only helps helps with that, but it also ensures that we're capturing all of the value add across the board for the GBS for projects. And the idea is that we will capture that, develop case studies, and report that back to our community, the Board of Regents, et cetera, to show the value of the new GBS. Okay, I did just throw these in here because we do have a lot of good resources on our website. We have these quick reference guides that Marilyn on my team developed that are awesome just for helping you get acquainted with some of the requirements in water, energy, embodied carbon, et cetera. We have an FAQ page, and then we also have a couple videos that are really helpful, particularly for folks that if you're really in the weeds on a project or working on a project for UW, you can go and look at the project tier video or reviews for PMs, and it gets into the weeds a little bit more than some of the other introductory videos. Okay, I think that's it. I was trying to stick to 10 minutes, so hopefully I stayed in that time frame, but here's contact info if you want to get a hold of me.
That's great, Lisa. Thank you so much. And yeah, you're good on time. Appreciate that. It's exciting to see UW's newest standards and you know, the resources that you have. So appreciate that. We're gonna hold questions until after the last speaker. So with that, I'm gonna roll to our next presenter. Oops, is Jesce Walz from Perkins and Well. Jesce Walz is a senior researcher at Perkins and Well. She approaches impact reduction with a focus on circular, carbon storing, and innovative materials. As a key member of Perkins and Will's research, she serves as principal investigator and strategic leader, developing design guidance, tools, processes, and initiatives to improve ecological impacts across the firm's global portfolio. Outside of her work at Perkins and Will, Jesce engages as a university lecturer, policy contributor, and active participant in groups like the International Living Futures Institute and Carbon Leadership Forum. Jesce, take it away. I'm gonna stop sharing.
Thank you very much. Should see.
See it. Yeah, you're on the.
Awesome. Okay, well, today I'm playing a little bit of a dual role. I'm going to share some things that I've learned about Western Washington University and their sustainability plans with specific focus on carbon. And then we're also going to look at a case study project and just, I guess, a slide here to explain that I work with our research group. I have an architecture background. I know many of you. And so maybe since we've talked, I'm working now with our firm-wide research, which works across studios, but I've been able to work on this project in both a design and a researcher capacity, which has been really fun. Here's a sneak preview of the project. And I'd like to begin by acknowledging that Western Washington University is located on the ancestral lands of the Coast Salish peoples who have lived in the Salish Sea Basin throughout time immemorial. And I'd ask you to please join me in expressing our deepest gratitude for the traditional owners of this land, the Lummi and the Nooksack nations, for their enduring care and protection of our shared lands and waterways. On this site also, Western, since about 1970, has been furthering ecological design. They established the Huxley College of the Environment, which is the oldest environmental colleges in North America, in the 70s, and they continue to cultivate a campus culture that celebrates this. So that was a part of the inspiration for the project that we're going to talk about. They also have a robust carbon reduction plan, and they're aiming for 15% carbon reduction by 2020, which is passed. This is their 2017 action plan. And then sustainable design standards for all new buildings with also focus on renovation. 100% renewable or clean energy procurement by 2030. Closed loop building operations to minimize waste and resource use, and then transparency and data sharing. These are their targets, and those were established when we started the project in 2019. One of the big challenges that came up for our project is that Western's campus is currently on a steam grid, and so that's a fossil-based steam grid. And they have a larger goal of electrifying their steam grid and transitioning the whole campus to electricity. The project we're going to share was the first electric transition on campus. It is connected to Puget Sound Energy because the campus transition is still occurring. But a 2022 feasibility study identified a plan for this district heating and cooling. It's happening through nodal systems that use Erin ground source heat pumps and low temperature hot water distribution. So those nodes will be placed throughout campus and they will operate depending on specific needs. So the residential part of campus is heating only. The buildings with more of an internal heating load that need cooling will have both heating and cooling. So this will be a huge impact in reducing carbon, and it improves efficiency and it sets the stage for full electrification to meet the campus's goals. So our project, or this project, is in schematic design and funding phases are moving it forward. And then simultaneously, there is a capital development and strategic action plan that goes alongside the sustainability action plan. This reinforces Western's carbon and sustainability goals, and it's a guiding principle for future projects. So again, this is reiterating the prioritization of reuse and renovation and infill to limit embodied carbon, and we know that's the first and most important step. And then also encouraging flexible, upgradable systems so that they can adapt to new technologies. So the electrification is just one example of that. And then new buildings that are going in will also be able to operate on that electrified campus system. And then coordination between campus utilities and buildings to support electrification. Working with utilities and operations to get the Kaiser-Bursari project off did take some communication. It's a different way that they've been operating. And so this is a really integrated and holistic approach that Western is taking to realize their values. This table is probably one to take a screenshot of, but I've just compared their 2017 plan to updates and implementation that have occurred since that plan was established and what the major considerations are of those. And so a highlight that I just shared is that capital vision plan favoring reuse and renovation. And then they're also doing GHG tracking through online platforms and increasing transparency, reporting on how things are going. There have been some goals that are delayed by funding gaps and staff capacity, but they continue to move forward. And I think that with decarbonization, it is easy to get discouraged in the face of what we have to do, but rigorous incremental commitment is really the way to go, and Western has been a great example of that. Kaiser-Bursari Hall is a flagship project that is pursuing not living building challenge, but actually net zero energy and net zero carbon, and those certifications are set to go through in January after we've had a year of consistent operation. So I'll share a little bit more about the project. This project is an electrical engineering and computer sciences building, and it's shown on the right. It connects to Western's existing communications facility, which is shown on the left, and together these form an advanced technology engineering facility. As I mentioned, this is a flagship project. It's meant to embody Western's future trajectory and a cornerstone to advance their educational mission. This is really a big step towards realizing the 2017 SAP and help the rest of the campus transition. And this is the project team who have been awesome. I'm going to share a number of analyses, and I just upfront want to give them credit, especially CPL, AEI, Mortensen have really come together with our team to perform carbon analysis. I'll share those with this group because I know that you'll be interested in them. And then some background, Western did come to the table with this project with a net zero energy goal. There's a donor who wanted to realize that. And at the very first meeting that we held in our office, we talked about the campus team and electrification and what would net zero energy really mean for their project. And then we also talked about mass timber and embodied carbon, as well as living future standards. And that conversation really took hold to set the stage for our team's collaboration throughout the whole project cycle. Western opted for electrification upfront and net zero energy, and then we chose to explore mass timber and living future standards. We followed through with rigorous performance criteria and designing with both those goals and the project budget in mind. This is a very straightforward project, and a part of the reason for that is to say that we could stay within this project's budget and still achieve those goals. Now, you may know that projects in Washington State are required to comply with LEED Silver. That's a requirement for all publicly funded works. Western's requirement was LEED Gold. This project pursued an alternative pathway, receiving permission to acquire Living Future's net zero energy and net zero carbon certifications. And the reasoning for that was that at the time, LEED did not focus as much on carbon, and choosing these two pathways in tandem allowed the team to really pour their energy into realizing those two goals. And though that pathway remains available to other Washington State projects, it's now been added to the revised Code of Washington. And then additionally, this project is a benchmark for future projects on Western's campus. So when they have a new RFP, this would be a goal that they would aspire to. It's a high goal, so not every project is going to get there right away, but it's an example. This is so from the rest of the presentation, I'm going to share some of my favorite slides. We have so much analysis on this project that I can't include it all or go through it all in the time that we have, but I'm just going to share with you some of our favorite analyses and then also project photos. This is an early analysis that we did with the team, just understanding where could we start working towards net zero energy as well as embodied carbon reduction alongside one another. CPL came in and they used Athena to do an early comparison of mass timber, concrete, and steel structure. And then we also looked at that in the EC3 tool, just recognizing that product-specific variability could influence what is really the lowest impact option. And so you see the variability in the kind of dashed or hashed areas in the bars that are to the right. CPL also did analysis of different structural deck options and identified the lowest impact option for the structural deck. We ended up using gypcrete topping instead of concrete topping. And that was a conversation to be had about durability and could we make that work with maintenance. And then site-wise, stepping back a bit from embodied carbon and into operational, campus here is beautiful. The site is really interesting. You can see over on the right of this slide an early rendering of what we had thought the project might look like. It's a bit more glassy than what we landed on. You can also see Seaholm Arboretum extending up to the right of the building there. And that is shading the project from early morning sun, which is going to impact the solar array. It also provides an amazing opportunity for connection to ecology. We identified right away that there is a pathway that is adjacent to the site going into the Arboretum. So we've said that our invisible staircase for this project is on the inside of the building, leading to the outside of the Arboretum. And this is a site section. We worked with a GIS analyst and our internal research to do studies where we got LiDAR data, estimated how much the tree canopy would grow over time and whether that would impact the solar shading. And here you can see project photos of this notch that is happening in the building that's opposite the staircase in the Arboretum, drawing attention to that. So if you're standing in the building and look out through that, you can see cyclists going by and people going up and down the stairs, which is a really nice biophilic moment. And then we worked with AEI to assess operational and embodied carbon together. The team was able to reduce the project's EUI target through improved envelope tightness and reduced window to wall ratio. And that synergized well with the embodied carbon goals. We reduced the curtain wall and we moved to a punched opening and then to a wood facade and analyzed design options of both of those, as well as daylight and views and how that would all interact. And then thinking back to that slide with Seaholm Arboretum, these are iterations of solar array that we did for the roof, looking at different spacings and tilts. Technically, the project would not have had to do solar because it's shaded enough by the Arboretum, but at the right tilt and placing the panels correctly on the roof, we're able to maximize solar potential despite the shading conditions. And here you can see some of the envelope design. We ended up going with an Akoya wood cladding and windows, and then there's some ribbon or there's some solar shading that is on the north of the building alongside a lounge where it's a bit more glassy. Partway through the project, we went through a VE process, and mass timber was always on the table. It was always planned in, but to get both that and electrification, we did have to do some VE. And I loved the team solution here, that we moved the basement from underground to more above grade programs. So that reduced excavation and concrete, increased mass timber structure, and reduced cost. And that ended up being a huge win for the project. And then for those of you who are really interested in embodied carbon, probably most on this call, you might have more questions about these. I'm glad to talk about them another time, but I'm just going to very quickly show some embodied carbon analyses that we did. This was looking at where would our mass timber come from and comparing regional Quebec and Austrian timber sourcing, and the red is transportation impacts. So we ended up sourcing from closer to the site in BC from Kolesnikoff, and we're able to visit their plant. That also bode well with the project's ecological story, understanding where our wood came from, and Kolesnikoff being a vertical supplier, we knew about their forest management process. And then we looked with CPL at the EC3 tool, identifying procurement goals. And so those included looking at the ready mix and the rebar and several other materials to get EPDs. And I'll show you in a moment the result of that. We did specify products with EPDs as much as possible. We also looked at different approaches to biogenic carbon accounting, so just to say that there are many different approaches that a project could take. Stepping back here, we ended up focusing on this third approach, which is that we used LCA data for our stage 3, C3, and C4 impacts based on what would most realistically happen with the wood, but we accounted for our biogenic carbon separately. So we show both biogenic and fossil, and we include both the C3 and C4 as well as the A1 to A3 biogenic impacts when we count that biogenic. Kolesnikoff also had EPDs, which is great to be able to review their process and understand more about their EPD development. And when we worked with the Tally data, because we did our analyses in Tally and their EPDs, we found that the impacts were pretty similar. You can see in each of these charts, Tally LCA's assumptions on the left, the installed product on the right for each CLT, glulam, and cladding. And then we did a similar comparison of modeled GWP and installed product for the other materials that were not mass timber. And in most instances, we saw a significant reduction between modeled and installed product. And then this shows all the products that we had EPDs for in the project, renewables on top, technical materials on the bottom, and just how much, even if we're not subtracting the biogenic or looping it in with the fossil, you can see how much value that biogenic carbon has. We looked at the metal straps and connectors in the project and their impact and found that they were pretty low. This is partially just because it was the project also did have some BRBs. We haven't broken those impacts out yet. I'd be curious to see that, but within the whole scope of the project, the metal connections that are typical of a mass timber project were not a massive driver. And they also allow for many of the elements to be disassembled in the future. We tracked the A5 impacts with Mortensen in a dashboard. We did Green Badger here. That could be a presentation in of itself. And then closing out, here's a finished classroom and an example of all of the LCAs that we ran throughout the project. So you can see from baseline through final LCA, we do have a significant reduction, but depending on what point you look at the project, since, you know, by concept, we had agreed to do mass timber, as you add more stuff to the project, the carbon impact increases. So I think reducing from a baseline can be a complicated conversation. This version shows the fossil impacts highlighted. And then this version is more baseline to mid-design to final. You see a trajectory of reduction. So closing out, you know, we did a lot of research and studies here, but we recognize that these have a huge impact, not just locally and regionally, but globally, and that they can help us to celebrate the ecology of place in Bellingham and through the project. This has been really fun to work on. It's great to see it completed, and we're looking forward to wrapping up the certifications over the coming months.
Thank you, Jesse. That was great. Thanks for sharing Western Washington's goals and initiatives along with the case study. Is wonderful. So We'll move on to the third speaker here. And if you want to start asking questions, you can put them in the chat, but we'll answer them after our last presenter, who is Erin Stocking. Oh, sorry, the title says Stocking, but it's Erin Hocking. Erin Hocking is the Corporate Reporting and Strategy Service Lead at Brightworks Sustainability. She works with various company types, but especially real estate owners and developers at various stages in their sustainability journey. Erin helps companies measure their greenhouse gas emissions and report emissions and sustainability progress to various corporate reporting frameworks, including GRESB, CDP, GRI, and SBT, as well as develop meaningful carbon reduction targets and strategies. For today's presentation, she will focus on how groups leverage corporate reporting frameworks to set targets and drive sustainability, especially through embodied carbon and supply chains. Okay, thanks for giving me alphabet to read off, Erin. I will allow you to share your screen and start your presentation.
Okay. All right, let me just move screens around. So yeah, thank you for that great introduction. I'll take the topic in a little bit of a different direction than the previous two speakers. So I want to talk about how we see clients leveraging some of the frameworks that we just talked about, and how setting carbon targets or reporting to frameworks can drive strategy. So beyond the company that's reporting, it can trickle down to those in the supply chain, architects, engineers, etc. So a little bit of a different topic, but hope it is relevant and interesting to you all. So again, just an introduction to two of the frameworks, and then we'll focus on GRESB and SBTI. There are many frameworks out there in the alphabet soup of corporate reporting, but just going to hone in on two for today. So to give a comparison, on the left-hand side, we have GRESB, which is the Global Real Estate Sustainability Benchmark. Some unique characteristics about GRESB is that this framework is specifically intended for real estate owners and financial institutions. So you may have heard of companies leveraging various corporate reporting standards. GRESB is, I want to say, the only one, if not in a small group of frameworks that is designed for real estate only. So while we do have reporting at a corporate level, GRESB really hones in on specific metrics and information that is specific to the unique real estate industry. How groups use GRESB is it is a questionnaire format where they will ask about general company sustainability practices. So they'll ask questions about sustainability policies, tenant engagement, various targets or other frameworks that a company is leveraging. So this is the representative from the company would go in and populate the questionnaire to best reflect the practices of the company. And then subsequent to that, there is an asset level spreadsheet, which is where I think a lot of the time and energy goes into this particular reporting framework. But essentially, this is an Excel-based spreadsheet where you enter performance data for all of the assets in your portfolio. So that performance data is primarily energy, in use, operational emissions, water, and waste. Also asks about any energy efficiency upgrades or green building certification. So a big focus of GRESB is getting the actual year-over-year performance data. That's something else to note about GRESB is it asks for data on a 2-year cycle. So this past year, we entered data for 2024 and 2023 because it's really about that year-to-year comparison in energy and emissions. And then finally, the way it works is that you earn a score out of 100. So you could get an 80, anything out of 100. And then you also get a ranking, a benchmark ranking against your peer groups. So if you are a shopping mall owner operating primarily in North America, you will get a benchmark analysis against other peers that have a similar use type, similar portfolio. This is something that our clients feel is very valuable, something that you don't get out of a lot of other corporate frameworks because you can actually see what categories you're performing better or worse than your peers. So for example, it would tell you if your peers are doing a lot more in terms of water, or if your peers have a lot more ambitious climate risk goals, for example, or climate risk reporting. So it's a good thing to leverage for understanding strategy and where an entity may need to focus more time and resources. And so I think that's one of the greatest benefits of GRESB. And then the other framework I want to talk about is SBTI, which stands for the Science-Based Targets Initiative. So a little bit of a different framework or standard. So this is actually a target setting framework designed to support entities in aligning reduction targets with a 1.5 degree future. So I'm sure everyone on this call has seen various claims of we want to be carbon neutral or net zero or reduce emissions 50% by a certain year. And the intention of SBTI is to get some common ground in language around target setting and some validity, especially with, some groups may claim that they are carbon neutral or net zero, but having the SBTI validated target is intended to give some validity to those claims in an otherwise a market that's pretty unregulated. And groups can mean a lot of different things from the claims or targets that they're setting. So essentially, if a company wanted to have a validated science-based target, you would submit your emissions inventory and reduction plans to the SBTI organization, who would review your plans and then ultimately validate your target if it is approved. The emissions reduction plan essentially has to dive into the various strategies you will use to reduce emissions. So whether that's purchasing renewable energy, engaging suppliers, changing purchasing, implementing policies for various scope 3 categories. So you essentially have to prove to SBTI that you are not only setting a target and making a claim, but you actually have a plan in place to reach the ambitious goal that you're striving for. There's specific target setting requirements and guidance depending on the sector. So there is a general corporate standard that can be pretty universally applied, but we also see specific guidance, especially for high emitting sectors. So I believe there's one for cement and steel, oil and gas, and I think most recently buildings got a sector specific guidance. So I'll talk about that a little bit more briefly, but some of these high emitting sectors, there is pretty specific guidance around what you need to do in order to make the claims and have a validated science-based target. So we'll zoom into GRESB a little bit first. I touched on some of this, but what makes GRESB stand out to the clients that we work with? I mentioned this with the peer benchmarking. So you get a customized peer benchmark report, which can be pretty difficult to find in sustainability today. It's something common we hear from our clients that you can read peers' reports and it can be very hard to parse through what they're doing and how that compares. So having the one-to-one comparison is really valuable and provides pretty meaningful insights to help organizations know how their efforts compare to others in their peer group. GRESB also focuses on real and high quality data. So I mentioned the asset level spreadsheet in the previous slide. And GRESB only allows you to put actual data in that. What I mean by that is you cannot use any energy estimates or water usage estimates, for example. This can be a challenge, especially for real estate owners that are leasing out something like an office building, or especially residential, where you probably do not have sight into tenant usage. So what GRESB really does is focuses on engagement between tenant and landlord, data sharing. A lot of times within corporate responsibility reports or sustainability reports, we'll see groups reporting greenhouse gas emissions that are made up pretty significantly by estimates. So it can be challenging to see how a group is truly performing, or what data they actually have, and how those estimates are made can vary quite significantly. So this is focusing on actual building performance and not an estimated number. And then the final piece of GRESB that we see our clients leveraging is how the asset spreadsheet separates out energy usage. So rather than just having a annual kilowatt hour or megawatt hour usage for the site, it encourages groups to separate out energy use for things like exterior lighting, parking lot lighting, electric vehicle charging. So this has been really beneficial for our clients in setting or understanding their EUIs more accurately and understanding actual building load, tenant load, landlord load versus other demands. And I think that can really help hone in on EUIs, which is one of the places we primarily start with clients that are looking to plan for decarbonization across a whole portfolio. So we're looking at things like, where do you have complete whole building data so you can actually trust this EUI? How do those EUIs compare once we account for things like on-site charging or exterior lighting if there's a significant exterior space? How does tenant demand compare to landlord demand? So GRESB helps to parse out data in a way that we would already look to do for decarbonization planning, which is something that has been great to see leverage through various groups that we work with. And then finally, with GRESB, wanted to touch briefly on how they are thinking about embodied carbon, since everything I talked about was just in the operational space. So just in this year's questionnaire, actually 2025, they introduced questions, and this is kind of the standard GRESB process, is they will introduce questions one year that are not scored, and then the following year, pending any significant feedback, they will have the questions scored. So we anticipate some scored questions around embodied carbon in the 2026 reporting cycle. And some of the questions they are starting to ask about are if groups have fit out programs. So any refurbishment programs for tenants, including upfront carbon emissions. So if there's any requirements for embodied carbon tracking, reporting, or target setting in tenant fit out programs. Also ask about green leasing and if there is any as-built requirements for embodied carbon or low carbon procurement or embodied carbon reporting through things like LCAs in green leasing requirements. And then finally, this is kind of a unique one, but it asks if entities do any type of risk assessment or embodied carbon assessment when they are looking for new acquisitions. So essentially analyzing how the embodied carbon of a potential acquisition would impact the portfolio. So that's a little bit of an interesting one, but something that GRESB is looking to. And yeah, again, this is just encouraging organizations to look into embodied carbon and ultimately compare to what some of their peers are doing. And those are just the indicator names. And then really quickly want to talk about SBTI, the Science-Based Target Initiative. So I just chose a case study to share. This is Equinix. For anyone that doesn't know, they're a large-scale data center hyperscaler. They have pretty ambitious sustainability, and they have a science-based target, which is committing to reach near net zero greenhouse gas emissions across the value chain by 2040, and a near-term target to reduce absolute scope 1 and 2 emissions 50% by 2030 from a 2019 baseline year. And thinking about embodied carbon, and I mentioned at the top of the call that sometimes setting targets can trickle down to those in the supply chain or those that these large organizations work with. So with Equinix, for example, as part of their target, they are committing that 66% of their suppliers buy emissions in purchased goods and services, and capital goods will have a science-based targets themselves by 2025, which of course is this year. So this deadline is fast approaching. I want to say last time I looked at their report, it was around 40%. So essentially what Equinix is doing is requiring that their suppliers, so that could be general contractors, architects, engineers, whoever they deem fit to make up that 66%, they are requiring that those companies also go through this process of setting a science-based target to ultimately reduce, their scope 1 and 2 and scope 3 emissions. So you can think of it as intended to be a ripple effect through supply chains, because as everyone on this call knows, the carbon reduction targets cannot be met through operations alone. And so supplier engagement and encouraging suppliers to set targets is a big way we're seeing this, I would say, trickle down through the industry. And don't have time to get too much into this, but did want to flag that there is a SBTi building sector guidance. So this is, again, specific for building owners and operators. There is a requirement to set targets for both in-use and embodied targets. And companies must set an upfront embodied carbon target if upfront emissions make up more than 20% of their total footprint. So in other words, if emissions from new development or major renovations make up more than 20% of total footprint, including operational carbon, then they will be required to set a target related directly to embodied carbon. And then this is a table I grabbed from this guidance, but they have emissions intensity thresholds of kilograms of CO2 equivalent per square meter for various building types. So yeah, I thought some folks on the call might think that these embodied carbon limits are interesting, and you can see how these scale from 2025 to 2050. So there's a lot here. I know I went through it quickly, but yeah, some good resources would be the SBTi website, specifically the building sector guidance. It's all available online if anyone's interested in learning more about that program specifically.
Okay, thank you, Erin. Wonderful. That was very insightful. There's been a couple of questions in the chat, and since we have only about 5 minutes left, maybe I'll start with a question that hasn't been answered in the chat, and this is from Chell. Chell, do you want to just ask it yourself, or you want me to read it? Okay,
Yeah,
I'll go for it.
Preamble in there. But it's about, connecting to a central system that is, my understanding is not going to be 100% fossil fuel free at Western or potentially at UW. And, we talk about ILFI certifications and they're awesome, but connecting to the central system or not is like a big deal. And, I heard UW saying connect to the central system because we will eventually decarbonize, so do that. And Kaiser Barsari is not connected to the central system, is my understanding, to get ILFI. So I was wondering if you two could talk a bit about that, because it's something we look at for most projects and has a big of an impact on how we approach certain things.
Lisa, do you want to start?
Yeah, sure. It's a great question, and it has come up a lot, of course, on the Seattle campus. It's something that our project teams are working on with ILFI, whatever certification path that we go down. They're trying to see what's possible, I guess. What we do know is that is a big priority for connection to the central plant is a big priority for UW at the central campus, because we really can't afford, with over 160 buildings, all of those buildings to have their standalone HVAC equipment. We can't maintain it. It's super expensive, and it's also much less efficient just in terms of total energy use, and it also allows us to connect those buildings to chilled water for cooling. So I guess to answer your question, because this is new in our chem sciences building, which is in the planning and development stages, will sort of be the first test of that question, and seeing if there's any exceptions for showing that we do have this. We just completed a large study with AEI and a number of subcontractors to develop an implementation plan to decarbonize the central plant. That's been submitted to the state because we're covered entity under the Climate Commitment Act. So to show them, like, we very much intend to do this. It also doesn't make sense for us to have all this standalone equipment for operational reasons, and just see what we get. If the answer, I guess, is no, we're not gonna make any leeway, allow any leeway for that in terms of the certification, then we're still gonna have Buildings Connect, and we will say, we won't get the official certification. We're okay with that, but we have to be okay with that because we can't go down the path of 170 individual systems, standalone systems. But great question. Thank you. Appreciate that.
Jesse, any extra thoughts?
I think Lisa expressed very well, probably alignment with Western's values, and that's why they're establishing the nodal system and moving forward with a more incremental plan for future buildings that they're going to electrify. It just makes a lot more sense that there's something in place, figure out how to use it. This particular project came in with a donor saying, I really want to have a net zero carbon building, and that was kind of the premise of the project, and the only way to do that at the time was to design for electric, and I think it was a good exercise to do that. Puget Sound Energy has very, very clean energy, especially if you're on their lower carbon green energy purchase. It's very low carbon, even as they're transitioning off of hydro. So, and then we have solar on the roof supplying some of the energy, and I think that Living Futures does allow for projects to have backup to district energy that is fossil based, as long as there is a transition plan. But I understand that changing a building that was designed to connect to the grid to the campus team is not necessarily easy. So that's as much as I know about it. And I think realistically saying this is what it would take to electrify everything standalone, and having that example versus studying what it would take to electrify or make the campus steam not be on fossil just provides them with a good counterpoint as well.
Great, thank you. There was just a question in the chat about the adoption of GRESB and SBTI. You can see that, but just out of respect for everyone's time, it's 1 o'clock, and I'll just leave it here by saying thank you very much to Erin, to Jesse, and to Lisa for this presentation today. Really appreciate it. And we look forward to future CLF events. I think we're planning a December meeting, so stay tuned for that announcement. So thanks a lot. Goodbye.